Hi, class. Today I'm going to talk to you about mean and standard deviation of the sampling distribution of sample proportions. So, a few definitions and examples or explanations. The sampling distribution of sample proportions. This is the probability distribution of all possible sample proportions denoted as p hat. Now, p hat, just so you all know, it's a p and it's got like a almost like part of a triangle on top of the P. Sometimes it's easier to write it out as if it were an exponent and it's like part of a triangle. Either way, when you see it, you'll know what I mean by hat because it looks like a hat. At any rate, it's obtained from samples of a specific size. So that would be N, how many samples you've got, drawn from a population with a true proportion. And we call just the proportion P. So we got that. Then you've got the mean. So if you consider population mean would be mu, the funny looking U, the proportion mean would be mu sub p hat. So it'd be mu with like a subscript little p with a hat on top of it. Also very hard to get that to show up. So sometimes it'll just be a p with a little exponent hat to the side, which is funny because that's as a subscript. But you'll see right away when you see it, you just go, oh, okay, that's a proportion mean. Anything that looks funny, it relates to proportions. And finally, standard deviation of the proportion mean. So that's going to be like, it's also known as the standard error. It measures the variability of the sample proportions around the population proportion. And there's an equation for that. But know that the symbol for the standard deviation of proportion, again, it's just like it was with the mean proportion. You're going to take the population parameter, which is sigma, and now you're going to subscript in like a p hat to show it's a proportion. So at any rate, that equation, if you were trying to calculate the standard deviation of the proportion of all sample proportions, it's going to be the square root of p times 1 minus p divided by n. All of that in a square root. So it's written out here in the discussion, so you can see what the equation looks like. Formula, obviously, it has to assume that sample size is sufficiently large for the sampling distribution to be approximately normal. And, if it's going to be a normal distribution, you should have an N of like 30 or bigger. Or you get things, a little bit off there. You can still use proportions with less than that and shift to like T stuff instead of normal stuff. But yeah. An example in nursing, suppose a hospital knows that 30% of its patients are readmitted within 30 days. That's pretty high. The nurse manager selects a random sample of 100 patients to study the readmission rates. The mean of the sampling distribution of the sample proportions would be 0.30 in this case, because that is 30% of the patients are readmitted within 30 days. So 0.30 is what we're talking about. So if you put that into trying to find like the standard deviation or standard error, that's going to be the square root of p times 1 minus p divided by n. So p in this case is 0.3. 1 minus p is 1 minus 0.3 or 0.7. So 0.3 times 0.7 is 0.21. And then you're dividing by n. And here n is 100. So 0.21 divided by 100 is 0.021. And then we're taking the square root as like the last step. And that becomes 0.0458. So 0.0458 is a decimal. If you want to convert that to a percent, just move the decimal place 2 spots to the right, and that becomes 4.58%. So that indicates that the sample proportion of readmitted patients will typically vary by about 4.58% from the true population proportion of 30%. So again, the hospital knows that 30% of its patients are readmitted within 30 days. When you run this, basically we get this number back that says, hey, the standard deviation of proportions is plus or minus 4.58% from that 30%. Okay. And I gave you a cool little link to libretext.org that goes over this again, sampling distribution for proportions. And I hope all this helps you all out in the long run. I'll be posting more stuff all week, so I'll talk to you later. Take care. Bye-bye.